So the question is, we need to determine the molecular formula of Y. So compound Y, dodgy Y, and it has a relative mass, formula mass of 58. And percentage composition of carbon 62.04%, hydrogen 10.41%, and oxygen equals 27.55%. So what we have to do, step one, is to convert these into grams. So if you assume, as you can see, all the percentages, this one, and this one, add up to 100%. That's a total thing. So if you assume that you have 100 grams of compound Y, just for the purpose of the calculation, you can then use these percentages, because 100%, you've got 100 grams and 100%, so 1 gram is going to equal 1%. So it just goes. So you can then say that you have 62.04 grams of carbon, you have 10.41 grams of hydrogen, and you've got the 27.55 of oxygen. 5%. Oh, sorry, that's not a percent, that's grams. So that all totals 100 grams, the amount you've assumed. So you've got the full complement there, which works. But when you start the calculations, write something like assuming that the sample of compound Y equals 100 grams, then boom, and then just start your calculations. It just lets whoever's marking it know that that's how you're doing it, and that's the correct way. So you might just get some extra points. It's just how you lay it out. Okay, now you know that now you know the mass you have of each. So because you know the mass you have of each, you can then calculate that from number of moles equals mass. It's a formula. Then that's from before. Okay, so number of moles equals to mass of substance over molar mass. And the last video, I showed you a triangle. It also follows here. So you can have mass only if I draw the triangle correctly, in the correct colour. So we're going to have better mass in the top, moles, and molar mass. So if you're wondering what that is, I did it in the last video on concentration calculations. I explained it. You put your multiplication in there. You don't need to, but you know that is. So there's a separate video on that. Right. So now you know the formula. Number of moles equals substance equals mass of substance over the molar mass. So what you can now do, you can put therefore the number of moles in carbon equals mass of substance, which we worked out, which is the same as a percentage, 62.04 grams, and that's over the molar mass, which is 12.01, which should be grams to the mole. And then you can write, you could put a C here instead. H equals, or you could put number of moles of carbon. It's a bit neater. Therefore, and just put therefore. Number of moles of carbon equals this, which equals that. So that will be 5.17 moles. Make sure you use the units here. Make sure you put the grams per mole here. If you know the grams here will cancel out each other in the calculation, that's why you're left with moles here. But we'll do that later in maths. H equals, that'd be just 10.41, but you'd have to say, because you have to write these things out. So, number of moles of H equals, that would be 10.41 grams over the mass, which just says 1 gram per mole, which leaves 10.41 moles. Number of moles of oxygen equals 27.55 grams. Now we've used this amount here, this amount here, and this amount here. That gives us our 100 grams that we started with, which is 100% of the sample. So that's how it works. Okay, so, and that's all over oxygen, which is 16 grams per mole. Which equals 1.72 moles. 1.72 moles. So we know how many moles we have in each one now, which is important for the next step. the next step in the process is we have to divide each of these 5.17, 10.41 and 1.72. We have to divide that by the lowest number. So the lowest one of these will be on the bottom of the fraction. Okay, so you'll see what I mean. This is the lowest one. That's the lowest value, 1.72. Okay, so you choose which one of these is lowest, which is 1.72. So what we'll do is we will now divide, so carbon, so you put you're working out the ratio, so you would put something like ratio is carbon, should I just use a C for carbon? Carbon, you can write carbon out full. I would write out full in this part actually. Carbon is, so 5.17, which we got here, which is carbon's, the number of moles of carbon. So we're doing carbon. So you get the number of moles of carbon there, and you divide that by 172, which is our lowest one of the three we chose, and that is equal to 3.01, which it approximates at 3, basically. Them lines is not exactly equal to, but it's near enough for us. So if on this step here, on the other page, you put carbon with a relative mass of 12.00, so there, if you decided that carbon had a mass of 12.00 here, which would probably be easier for the calculation, it would be fine. So just do that. And it will save you a bit of trouble here. So carbon 12.00. Okay, carbon, so that's 3.01. Hydrogen is 10.41 over 10.41 is our number of moles of hydrogen, remember? And that's over the same number, 1.7, it's the lowest number, it doesn't change. It's a ratio, that's equals 6.05, which is approximately 6 for this purpose. Again, what did we do for hydrogen here? Okay, yeah, that's fine. Hydrogen and oxygen that is our lowest ratio, so it's just basically 1.72, which is the number of moles of oxygen, divided by the lowest, which is oxygen, 1.72, which is going to equal 1. So the simplest, so you'd write, make sure you write this out, something like this. Therefore, the empirical formula is of compound Y is 3, which is your carbon. Here, 3. And then these 2 dots mean there's a ratio to 6, which is this one. So that's where the carbon goes. That's where the hydrogen goes. And the oxygen, which is 1. So this is the empirical formula. So that's the numbers in the empirical formula. So therefore the empirical formula is which so the empirical formula, you could actually not put put here the ratio of carbon, hydrogen, oxygen, and write it like that, of in there, so therefore the ratio of carbon, hydrogen, oxygen in compound Y is 3 here, 6 here, which we calculated, and 1, which is there. So 361, which gives the empirical formula of carbon first, C, because we know there's only carbon, hydrogen, oxygen, so we're going to write basically this one and that number for each one. It's a ratio. So carbon 3, which is there, hydrogen 6, which is got from there, and oxygen, which is there. We don't write the 1, do we? So the molecular formula is, the empirical formula is C3H6O. So now we are most of the way there. All we need to do now is calculate. We need to calculate the molar mass of the empirical formula. So, well, we'll assume that carbon equals 12 because we did that earlier. So carbon equals 12. You could put you could write this out if you wanted to do it to see if you can get some extra points. As carbon, just put carbon has a mass of 12 or something, but I'll just do it shorthand here to save space. Carbon 12, hydrogen 1, oxygen B16. All we need to do is add these up. So 1 carbon has a mass of 12, but we have 3 in the formula, don't we? We have 3 over here. So we just need to do 3 times 12. So that's 3 molecules of carbon. 1 is 12, so there's 3 of them. So it's basically 3 times 12 plus, because we've got a hydrogen there as well. There's going to be plus 6, because we've got 6 hydrogens, times the mass of hydrogen, which is 1. So that covers those 6 here. Plus oxygen, which is just 16. I'll put 1 times 16 just for clarity, because the other ones are done like that. And that equals, I'll put it here, 30. 36 plus 6 plus 16, which equals 58. And that's going to be grams per mole. So the mass of this compound Y is 58 grams per mole. Now, we were told at the beginning the molecular mass is actually in the question. So compound Y has a molecular mass of 58, which would be grams per mole, by the way, but they didn't put that in the question. So you can see here that our answer is 58 grams per mole with this number of, if we had, like, say, another carb, another hydrogen, or whatever, however, if we had any more or any fewer elements in there, it will change the mass from 58 grams per mole, because these numbers here will be different. So we've got, and so it can't be any other formula for a mass of that 58 grams per mole. So we know now that our compound Y is 58 grams per mole. So it has to have this formula, which is the empirical formula, but we're asked to give the molecular formula, which is the empirical formula is a ratio. The molecular formula is exactly how many of each one there are in there. So, but it's the same, because if we had any more, it would be a different mass. So we could say, we have to say this, by the way, it's important, or it's cause some problems. So we could say the answer, therefore, at the bottom, not at the top, I'm just running out of space, therefore the empirical the empirical formula is the same as the molecular formula. This being C3H6O. And then below that, I'm just going to write it in the middle because I'm around, there's room here. Therefore, the molecular formula of compound Y equals C3H6O, which makes sure that you answer the question, what the question's asking. So you've answered that right at the end. So even all these other bits you put here, doesn't matter as long as it's correct. If you've answered the question, you've answered the question. You've answered exactly what it's asking for. Yeah, so that's your answer. C3H6O, and that's how you do it. So you just, it's the same as the empirical formula. It's not always, but in this instance it is. So we're quite lucky. Make sure you show your calculations and make sure you use grams per mole and the units afterwards, or you'll lose marks. Grams here. Yeah, you can do that. Make sure you show all these grams per mole and stuff there. everywhere. Basically, use all your units. Moles. Show all your work in, lay it out nicely. Put the formula you're using. Put your formulas down. And that's how you do it. And that's your answer.